In this video, we will review the InfiNet Wireless GPS synchronization module for the InfiLINK 2x2 Pro and InfiMAN 2x2 base station sectors. The AUX-ODU-SYNC is a TDD synchronization hub which has been designed to provide a timing reference for the InfiMAN 2x2 base station sectors as well as for the InfiLINK 2x2 Pro units, so for all radio devices based on the 808 platform. It has an embedded GPS GLONASS receiver and an active antenna. It helps eliminate the mutual interference between multiple collocated units. Alongside the TDMA-based firmware, it enables you to implement frequency reuse within the same site, or the so-called ABAB system. In case of relay sites, by installing the AUX-ODU-SYNC at the retranslation point, it is possible to use the same frequency on both links. And in addition to its main function, the synchronization unit also provides the geographical location and precise time reference for all connected devices. The AUX-ODU-SYNC features an all-in-one design. The GPS GLONASS receiver, the antenna, and the timing distribution scheme are all housed in a low-profile enclosure, which guarantees quick and easy deployment. It has 8 ports, one for the power supply and the other 7 for the radio devices, so it can provide synchronization for up to 7 InfiNet Wireless units. The sync device is protected against water and dust according to the IP66 and IP67 ratings, and its maximum power consumption is 4 watts. By default, the AUX-ODU-SYNC is supplied with the IDU CPE power injector, but almost all other InfiNet injectors are compatible. Next to the power port of the device, there is a set of 2 LED indicators. During optimal operation, the power LED lights up in solid red, while the sync LED is green and it's blinking. Now let's see what happens when you implement frequency reuse with and without synchronization. First, without the ODU-SYNC, the recommended guard interval between the frequencies of the adjacent channels is equal to the channel width, which in this example is 40 MHz. But mutual interference will still be present because at certain points in time, one of the base stations might be receiving while the opposite sector is transmitting data using the same frequency. As you can see in the picture, the problems appear mainly at the reception because the signal coming from the opposite sector is more powerful than the useful signal from the distant subscriber. To reduce the effects of mutual interference in the absence of synchronization, a large distance separation of 2.5 to 3 meters must exist between the sectors that use the same frequency. If this separation cannot be achieved, you will need to use different channels for all sectors in order to eliminate the interference. On the other hand, if you deploy the AUX-ODU-SYNC device, all 4 base stations will send and receive data at the same time, thanks to the GPS synchronization. This means that the same frequency channel can be used for opposite sectors without having to worry about a big distance separation and a large guard interval. The units can be installed back to back, and the guard can be as small as 5 MHz in most situations. So, with the AUX-ODU-SYNC, a 4-sector site can operate using only 2 frequency channels, which significantly increases the spectral efficiency of the system. Before connecting the AUX-ODU-SYNC to the base stations, you must go to each InfiNet Wireless device in your network and check to see if the TDMA firmware is installed. If the current firmware is TDMA-based, please make sure that you have the latest version. In case your firmware is the polling-based one, which is also called Mint, then you must upgrade all your devices to TDMA. You can find the TDMA firmware files for all hardware platforms on our FTP server. And if you need more instructions, there is a detailed procedure on how to upgrade from Mint to TDMA in one of our previous screencasts, or you can go to our website by following this address. Also, I want to mention a few limitations that you should be aware of when using the AUX-ODU-SYNC. First, the frame size and downlink uplink ratio parameters must be fixed and identical on all synchronized devices, otherwise the synchronization will not work. Then, the 14, 15 and 30 MHz channel widths are not recommended for use with TDMA, and the 28 MHz bandwidth is fully inoperable with the TDMA-based firmware. As I mentioned earlier, the connection between the AUX-ODU-SYNC and the InfiNet Wireless devices is done using special proprietary cables called cab sync, which must be ordered separately. As you can see in the picture, the cab sync connects to the console port which is present on the 808 devices namely the InfiMAN 2x2 base station sectors and InfiLINK 2x2 Pro units. To enable synchronization, all you have to do is simply go to Basic Settings, Link Settings, RF50 in the web GUI of each connected unit and check Use AUX-ODU-SYNC. Then click the Apply button. Or you can also do it from the CLI, go to the command line section or log into the unit via Telnet, then enter the tsync enable command. And finally save the setting by using the config save command. The synchronization mode information can be displayed in the command line section using the tsync command. The time offset histogram is shown. In the bottom of the histogram you can see the extreme values of the time offset and jitter. The status field displays the current status of the device. The total enabled field shows the total time during which the synchronization unit has been enabled. The total valid and valid time fields indicate the period during which the timing accuracy has been better than 10 microseconds. The lost count field shows the number of synchronization interruptions. And finally, the last message field displays the last message received from the synchronization software. Additionally, in order to get the device coordinates, GNSS position can be enabled. In the web interface, go to Basic Settings, System Settings, check the Enable GNSS Receiver box, and click the Apply button. Then click Open Map to view the device location on Google Maps. The location is updated in real time, which is very useful when your InfiNet devices are installed on mobile objects. Also, you can check Use GNSS Time to synchronize the system time with the global satellite system. In order for GNSS time to work, the GNSS receiver module must be priorly enabled. The current synchronization state is displayed in the device status window in the top right corner. Here you can find information about the synchronization status and the number of visible satellites. If the synchronization is enabled and it works properly, the indicator will show the time since the last successful sync. In this case, the time is 0 microseconds, so the synchronization is perfect. Also, you can open the map from here as well by clicking on the Sat button. The GNSS receiver can also be enabled from CLI using the GPS start command. And more detailed GNSS statistics can be displayed using the GPS stat command. The total GPS time field shows the total time of GPS operation. The total non-valid time field displays the total time during which the coordinates information has been unavailable. The number of losses field shows the number of situations when the coordinates have become unavailable. The next field displays the interval since the last time the coordinates were received successfully. And finally, the satellite's histogram shows the distribution of the visible satellite numbers. The minimum and maximum numbers of satellites are also displayed. This brings us to the end of the video. Thank you for watching.